Hey, welcome to lesson 5.3, maximums and minimums in linear relations. So by the end of the lesson, we should be able to determine the maximum and the minimum given an equation. So again, we're just going to jump right into some examples here. So in example 1, we have an equation C equals 20n plus 35. It represents the relationship between the cost of school volleyball uniforms, C in dollars, and the number of uniforms ordered, N. We want to complete the table of values and then graph the relation. Okay, so they gave us this equation, C equals 20n plus 35. So from our equation, we should recognize that when we have 0 uniforms, our initial value is 35. And then we also know, right, this is our initial value, and we also know that this is our rate, which means that for every one uniform ordered, it costs $20. But in this case, it's skipping up by 5s. So we know that 20 times 5 is 100, right? So every 5 uniforms is going to cost an additional $100. So every time we go up one, we should be going up by 100. So we've got 135, 235, 335, 435, 535, 635, 735, and 835. Okay. So then they want us to graph this as well. Okay. Okay, so our independent variable, this would be our number of uniforms. This is our 0. And then over here is our cost. Okay, so number of uniforms, right, we could go up by 2.5, so like skip count, we can do by 5s. Okay, and then here's one of the times where breaking a graph would be appropriate. It will just make our life a little easier. So if we break right here and then we start at 35, and then we can choose our scale, right? It would be pretty annoying to try to figure out a scale that's going to work for a number as small as 35 and then a number all the way up to 835. But in this case, we can see we can just count by hundreds. So it makes everything pretty simple. And I'm going to spread it out too, so I'm actually going to count by like 50s. So I'm going to skip a spot every time. Okay. Oops. Wow. I failed at that. I wasn't paying attention. I was counting by 10s instead of by hundreds. So let me just try that again. Oh boy. 135, 235. Yikes. Okay, that's a little bit better. And we need a title, so I'm just going to call it uniform cost. Oops. Okay. All right, so then let's graph this. So at 0, we've got 35. 5 is 135. 10 is 235. 15. 20. 25. 30. 35. 40. 45 and 50. Oh wait, no, 50 doesn't fit. Take it back. Alright, so let me draw a line here. Hopefully a somewhat straight one. There we go. Okay, so we've got a graph here. This also tells us that the uniform company requires that the school order a minimum of 15 uniforms. The school has a maximum of $600 to spend on the uniforms. So, what's the minimum value of N? Well, right here, we have to order a minimum of 15 uniforms. So the minimum is N equals 15. That's the number of uniforms. What's the minimum value of C? Well, this we can figure out. right? We can use our equation that they gave us, C equals 20n plus 35. And if we sub in for n, we get 335. So that would mean that, therefore, the minimum cost is $335, right? You have to order 15, that's what the company requires, so you are at least spending $335. Now the maximum value of C, right? The school said that they could spend at max $600. So if we take a look here, we want to figure out the maximum value for n. So in this case, we're going to plug in, or we're going to use our equation again. But now we want to figure out how many uniforms could we actually get for this $600. So if we move this 35 over, we get 565 divided by 20, and n equals 28.25. Now, when we get these types of questions, we have to be careful. You can't just say that the number of uniforms that we could get is 28.25, because we can't buy a quarter of a uniform, unless maybe we're just buying some socks or something. So we're going to have to change this number to make it a real life answer. So therefore, the max value of n is 28, right? Whole uniforms. Okay. So second example here, we've got this equation, C equals 45n plus 650. It represents the relationship between the number of people attending a wedding and the total cost. So what does C and n represent in this situation? So C is the total cost, and n would be the number of people attending. So what does the number 650 represent in this situation? This is our initial value. Okay, so this would be the $650. It could be like a setup fee or a hall rental fee. We want to know, what does the number 45 represent? So that's the rate. It's $45 per guest. Right? So that would be like per person or per plate, right? At a wedding, you're usually paying for the meal. Okay, so Cheryl's planning her wedding, and she would like to keep the guest list to a minimum of a maximum of 250 people. What are the possible values of C in this situation? We want to justify our answer. So we've got the minimum C. Well, minimum would be like if she didn't invite anybody, right? So in this case, we'd use our equation, C equals 650 plus 45n. Well, if 0 people got invited, which would be an awfully boring wedding, it would just cost her $650. The maximum, right, maximum C, maximum cost here, well, she wants to invite a max of 250 people, so we're going to put in that for our number of people. So, and that gives us a total of 11,900. So we could say, therefore, the cost ranges from $650 to $11,900. Quite the difference. Okay. And then last here, Kevin is planning a wedding. He would like his cost to remain under $10,000 and knows he wants to invite a minimum of 175 people. Determine the possible values for N and C in this situation. Okay, so this is minimum right here. This is our minimum, and it's C. Okay, and then this is our max cost, right? Minimum cost and maximum cost. So let's figure out here our minimum number of people, which would give us our minimum cost. And it's still the same equation because they haven't told us it's a different hall yet, or at all. Right? So again, if his minimum number of people he wants to invite is 175, 45 times 175 plus 650, we end up with 8,525. Then we also want to figure out his max people with his max cost. So we've still got our equation, but now if he wants to spend a max of $10,000, right, if we subtract over here, right, that's 10,000 minus 650, we get 9,350, and then divide both sides by 45, and gives us 207.8, but again, we can't have 0.8 of a person, so just 207 people. So we could say, therefore, the minimum number of guests is, is 175 at a cost of 8,525, and max guests is 207 at a cost of 10,000. Okay, so nice short sweet lesson here, just the minimum, maximum, being able to read those questions. So again, try the homework and ask questions.